All right, it's Mr. Precal with Precal. This is Unit 3, Topic 2. This is Lesson number 1, which happens to be graphing trig functions. Now, this is a quick warm-up of what you should have already learned in Algebra 2, is that sine always starts at the midline, so at 0 degrees it has a height of 0. If you think about the unit circle, it kind of makes sense. And if it's cosine of x, cosine either starts at the maximum or minimum. So that's this one. So they're both sinusoidal, which means that they have that wave sort of pattern. They look exactly the same. In fact, if you shift them left and right, they would be exactly the same thing, which we'll get to on the third video. Tangent of x, tangent happens to be choice B, which is this one right here. It's got these undefined asymptotes. That's the clear way to know that it's... Keep in mind that tangents can be any height, technically. It does have a range of infinite because one side of a triangle can be way bigger than the other side of the triangle, so therefore opposite over adjacent could be a really large number, whereas sine and cosine have to be between -1 and 1. Cotangent would be the exact same thing as B, which that would be F because it's going down. Now, these two can very easily be mistaken, cosecant and secant. Cosecant, remember, is the reciprocal of sine, and sine is at 0, which means at 0 degrees it has 0 as an answer. So therefore, if you do the reciprocal of 0, it would be undefined, which the reason why sine is undefined on the reciprocal, so that would definitely have to be choice D. And then secant would be by process of elimination, because if you think about it, at 1, it's got a height of 0, which means that's going to be undefined, so it's going to be undefined right here, after it's gone 90 degrees. So whatever this equivalent is must be to that, whatever, because there are no technically units on these, so we don't really know. All right, so basically what I just talked about, so we're going to go through the parent functions of cosine and sine first. Now, this is, you should know that this is cosine comma sine. Whenever you have a coordinate on the circle, it's always cosine and sine because cosine is always the x, because it's x over the radius, which the radius is 1. And sine is y over r because it's the height of 0 over the radius, which is 1. 0 over 1 is 0. All right, so I'm just going to plot for sine all the second digits. 0, 0, 1, 0, negative 1. 0, 1, 0, negative 1, back to 0. Do the same thing on the, if I go opposite direction. So -1, 0, 1, 0. And it looks just like this. And it has that look to it like it's like a wave. Cosine does the exact same thing because remember cosine is the x. So I'm just going to start here. We always go counterclockwise from the starting position. So that would be from, 1, 0, down to -1, back to 0, back to +1. Just ignore that one dot that I have right there, and it goes like this. All right, sine always starts at the midline, and cosine always starts at the maximum or the minimum, depending if the amplitude is positive or negative, which I will get into. Yes, the graphs look pretty much exactly the same. They have the exact same domain, which is all real numbers, and they have the same range from -1 to +1. They do not have the same starting points, but like I said, if you shifted one back and forth, then yes, it would be the exact same thing as the other one. So what about 2 times sine of x? Now, this 2 in front is a amplitude, which is also known as the vertical stretch. It tells you how high and low, it tells you where the minimum and maximum will be of the graph. So it's sine of x, there is no translation up or down, so it's not going to go up 1, now it's going to go up 2, then back to the midline. So really, this is going to be the maximum height, this is going to be the midline height, and this is going to be the minimum height. So all the points are going to be on one of those 3 dotted lines, and you're just going to basically keep weaving back and forth. So from midline to top to middle to bottom, to middle to top to middle to bottom, back to middle again. Now, for -3 of cosine, now keep in mind, as I said before, cosine always starts at the maximum or minimum, and it's going to start at the minimum because it's a negative amplitude. So the minimums are going to be on this dotted line, the midline is going to be on this dotted line, and the maximums are going to be on this dotted line. So I'm just going to go to midline to maximum to midline down to minimum. Do the exact opposite on the other side, connect your dots, and there's all your answers. Everything in between -3 and 3 is a possible answer in this equation. Okay, so now we're going to introduce, well, what if there's a midline is changed? What if there's a vertical shift? This +1 means the midline is now at 1. And then you do exactly the same thing. So sine always starts at the midline. It's -4, which means I'm going to go down 1, 2, 3, 4. So this is the minimum heights, 1, 2, 3, 4, and this is the maximum heights. So it goes down here, up here, and back. So that's what our graph looks like from 0 to 2 pi, and then I do exactly the opposite when I do from 0 to -2 pi. And there's 2 complete waves, one in front, one going counterclockwise, and one going clockwise. All right, so this one's got a midline height of -2. It's got an amplitude of 3, 1, 2, 3, so this will be the maximum height, 1, 2, 3, and this will be the minimum height. So all points have to be, all the key points have to be on those 3 dotted lines. Now, I'm not saying that those are the only heights possible. Those are not the only, that's not the only ranges. Anything in between can also be the range as well. So cosine means I'm going to start at the maximum because it's positive, down here to here to here and back. Do the same on the opposite side, and voila, you've got yourself a graph. So the +1 just means up 1, and the -2 just means down 2. So that's the midline. These are very similar questions to what I just did. So -1 is here, 1, 2, 3, 4. So I start here, down here, 1, 2, 3, 4, back and back. And same thing on the other side. All right, so the graph looks like this, and this one starts at -3. Sine goes down a half like this. So you're going to notice that when the amplitude is 0.5, that the graph is, okay, that's why I need to do key points, clearly. That means the height is not going to have a very big height going up or down, and unfortunately it's not letting me. Okay, so it's going to be something like that. Okay, but obviously that's a good reason why you need to put the points there, because I didn't do a very good job of that. All right, so now what was different about this equation is the fact that it's 2x. Now, what that means is that it's going to do 2 cycles for every 2 pi amount of time. That's the B term. So in order to find the period happens to be how long it takes to complete 1 full cycle. You're going to divide 2 pi divided by whatever the period is. Because 2 pi represents, 1 full circle on a unit circle, and if we divide it by, if it does 2 cycles per unit circle, then that means it's going to tell us that it takes pi amount of times in order to complete 1 cycle. Pi to do the first cycle, another pi to do the second cycle, therefore it does 2 cycles in 2 pi amount of time. All right, so we need to consider where our key points are going to be along the x-axis. If it's going to take pi amount of time to complete 1 cycle, then it's going to take half of that in order to get halfway to the end. And it's going to take half of that in order to get to the midpoint of 0 and half a pi. And then in between half a pi, so this is 1/4, 2/4, this is 3/4 pi, and then 4/4 pi. So now I know how to set up the increments along the x-axis. Pi over 4, pi over 2, 3 pi over 4, and pi. All right, and now I can set up my increments going up and down. I know that it's got a midline of 0, so I'm just going to put that dotted line here. And it's got an amplitude of 3, 1, 2, 3, so 3 and -3 will be our maximum and minimums. It's cosine, so it's going to start at +3, down to here, down to here, down up to here, and then right where I'm at is where it's going to finish. 8.5 minutes. Okay, I'm going pretty good time. -2 is the midline, 3 is the amplitude, and 1/2 is what affects the period, as I mentioned. That's the B term. So we can use that 1/2. So we know it only does half a cycle for every 2 pi amount of time, which means it's going to take twice of that. So keep in mind, anything that's on the inside of parentheses is usually the opposite. So when it's a fraction, that actually makes it take, it's going to make it wider. And if it's a bigger number, it's actually going to make it skinnier. Bigger numbers make it skinnier. Key points. So 2 pi divided by 1/2. So leave change means 2 pi over 1 times 2 over 1. Leave this alone, change the multiplication, change this to the reciprocal. 2 pi times 2 is 4 pi. So we now know it takes 4 pi amount of time in order to complete 1 full cycle. Half of that would be 2 pi, half of that's 1 pi, and half of that is 3 pi. Pretty easy there. So that's how I'm going to set this up. All right, and now setting up my increments. So now I know 2 is the midline, -2. 3 is the amplitude, 1, 2, 3, so that's -5, and that's +1. Sine means it starts at the midline. It's positive amplitude, so up, down, and then back, like that. Okay, so the map. The midline is +1, the amplitude is -2, and the period, well, 2 pi divided by pi is 2. So I know 0 to 2. So 1's in between. So 1/2 and 3/4. Oh, I'm sorry, not 3/4. Oh, it's not going to let me do that back. It's going to be 1.5, which is 3/2. Not pi, just 3/2. Okay, so this will be 1/2. This is 1. This is 3/2. This is 2. So that's 1/2, 1, 1.5, and 2. And 1 is the midline, and 2 is the amplitude. So that means this is 3, and this is 1, 2, -1. All right, so -2 just means it starts at the bottom, then here, then here, then here, then here. So there's your graph in a nutshell. Okay, so it looks like I just have to have more examples of the following. Let me just do these two right here. So let's see, 2 pi divided by 1/4. So that's 2 pi times 4/1, which is going to give us 8 pi. All right, so we know 0 to 8 pi. We know 4 pi is in between. In between those is 2 pi. In between these two is 6 pi. So there's how I set up my increments. All right, so I set up my increments going up and down. So the midline is 0, and the amplitude is 2, so -2 and +2. And it's cosine, so it starts at the minimum, and up here, then here, then here. All right, one more example, and I'm going to move on to the next video. So let's see, 2 pi divided by 1/2 is 2 pi times 2/1. Which is 4 pi. So 0 to 4 pi, 2 pi is in between, 1 pi is in between, and 3 pi is in between. So pi, 2 pi, 3 pi, 4 pi. All right, so 1, 2, 3 is the midline. 4, 1, 2, 3, 4. 1 is the height, and 1, 2, 3, 4. So what is that? -3 minus 4 more makes -7. Okay, sine starts in the midline. It goes up because it's positive. I know it's not the cleanest looking graph, but hopefully you get the idea. All right, thanks again for watching. And on the next video, I think we're going to take care of phase shifts. All right, thanks again. Have a great day.